can you please download the Excel spreadsheet that I posted, which is length statistics?
Hey, Professor, is it the length statistics one?
Yes, this is a length statistics. You can find that spreadsheet under module.
Thank you, I just found it.
So this is a module, and I posted a 2 worksheet, the length statistics worksheet, and then thermal expansion statistics worksheet. And by the way, the second one will be, the quiz. So I already posted, which is due before next week. So what we're gonna do in this class demo, we have the length measurements, okay? So we have 8.57, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 measurements of something, okay? Then we want to determine the error percentage, E90 and E95 of this data. So in the Excel, of course, it has a function to calculate the average and the standard deviation and those, but we're not going to use those functions. But we will actually follow the procedure that I explained on the slide, okay? So then we have I, which is number of trial, number of measurement, and then we have MI, which is a measurement observed value. So this is a meter. Okay, then to calculate the sample mean, what should we do?
Add those numbers, the MIs.
Yes, so then we need the sum of this observed value, right? So then to do that, do you guys see my screen, Excel?
Yes.
Yes.
Okay, very good. So then to have a sum is equal to sum, and I need to determine the range of it, right? And then we get the sum. So this portion is I'm going back to the slides. So this is a sample. Oh. This is a sample mean, and then this portion, the summation of this is this, right? Numerator. And we need to divide this by n. So then I actually put the n here. So it is obvious that we have a 10, right? So then you can type 10, but if you want to make it, you know, more flexible or functional, what you can do is you can put equation count, so that it will count this number of observation, right? So then it will be 10, right? And how we can calculate m bar?
We divide our sum over n.
Sum
Well,
divided by n, right? So then sum divided by n. So this is the m bar. And now we have a standard deviation, right? Standard deviation, we need what? VI. What is a VI? VI is
M bar
residual.
minus mi.
Yeah, residual, which is observed value minus m bar, right? So I'm going to put V, which is, I showed you two different ways to calculate the book, the way that the book use or the actual that we're gonna use. So the MI minus M bar, okay? So I'm going to use this one. So is equal to this MI minus M bar, right? But this M bar will be used repeatedly, right? So I'm going to fix this M bar by pressing F12, I believe. F4, right? Then you can see that then the number changed to the dollar sign, which means that the first one will, if I drag that, and then this will be changing, but this dollar sign ones will not change. So then we always use this value. And this becomes, the residual of the first one becomes 0.093. Let's make it a little bigger so that you can see better. Okay. Then what I'm going to do is I will drag it down. So then if I click the second one, the first one, what? B2 minus this, right? And second one is B3 minus this one. So then again, by putting the dollar sign, then we always, fix the location for M bar, okay? And to change this, either you can type the dollar sign or you can press F4. Do you have any questions so far? And this is inside of this square root, right? And then what we need is we need to square them. So the second column I'm going to do is V2. And V2 will be what? This is to be squared, right? Power of 2. And then I'm going to double click or drag it down. And the bottom line, this row is a summation, right? So then I will have and I'm going to use different color for that. One question for you. What will be the summation of this residual? Uros answers at 0. Elijah says it's 0. V2 is square root of VI. Christopher says it's 0. Do you also agree? Is it 0? So residual by definition, right? Residual is the difference of the observation to the mean value. So then if you're adding all of this up, then that should be either 0 or very close to 0, right? So let's do that. Sum of so then you have a 0 value. And then this V2 is square of VI, right? And then what we do is we need to sum. The sum of these values. Then you have the numerator part is done, right? And how we can calculate the standard deviation. Standard deviation can be calculated. Square root this one divided by n, which is 10, minus 1. And you have a standard deviation. We have a dispersion here, right? What is the definition of dispersion? Yes, the difference between the highest value and the lowest value, right? That's correct. So then to do that, you have max of observation, right? Minus mean of observation. And this gives you dispersion. Any questions so far?
Wait, what is dispersion again?
Dispersion is the largest observed value minus smallest observed value. The final step is to calculate E90 and E95, right?
Professor, can
Yes.
you show how you do the dispersion again, please?
Okay, so then dispersion can be, okay, I will erase and then do it again. So dispersion is the maximum observed value minus minimum observed value, right? And this column is observed value. So dispersion is equal to max of these values minus mean of the same values, right? Then you will get dispersion.
Okay, got it. Thank you so much.
No problem. And
Could you do the standard deviation again? Because it's not working for me.
okay, standard deviation, again, by definition, square root of dispersion square, summation of dispersion square divided by n minus 1, right? So what I did is equal to square root d12, which means this one. This is what the summation of, the residual square divided by n, which is h1 minus 1. Then you will get the answer. Do you have other questions? Okay, not then. Then the two we have what E90 and E95.
I actually have a question, Professor, real quick.
Okay.
So for the dispersion, we're supposed to use the biggest value and the max value and the minimum value, but they're using for the dispersion B10 and B8, so 8.55 and B.46, which neither is the largest or the smallest value.
So
shouldn't we be using 8.74 and 8.33 instead of 8.55 and 8.46?
if you have a max,
oh
then
wait, no,
you will find the maximum value, and then if you use a minimum function, then you will find the minimum. So it will calculate for you.
I saw my mistake. It's okay.
That's okay. Other questions? All right, then we have 3 more to calculate: E90, E95, and the number of beans. So, for example, 95% error can be calculated 1.9599 times standard deviation, right? So I will leave it to you. So I will give you time to do it, and then I will give you as a quiz. So why don't you calculate the E90 and E95? And also the number of bean by the Sturgis rule. I will show you the slide again. One plus 3.322 log base 10 n, right? So why don't you calculate those 3 quantities? All right, so I will show you the answer, and then that will be all for today. So E90 can be calculated 1.6449 times standard deviation. And E95 can be calculated 1.9599 times standard deviation. And number of bean can be calculated 1 plus 3.322 log 10 times 10. Let's see. Oh, okay,
Professor, it looks like those values changed.
Oh, the reason is, I see what happened. The reason is I typed 8.47 here, and then I typed 8.74. So if I change the 8.74 to 47, then that should be the same. So this is actually the typo. So then we have 8.47.
What?
So then
So
the rest should be the same.
In the spreadsheet you gave us, so that was wrong then.
Okay, then.
Yeah, that's 7.
Oh, okay.
8.
Yeah, yeah. In fact that I fixed it, but when I posted, I actually posted the wrong one. For the quiz, I will make everyone correct, but because you use 7.4, right? And then my answer is based on, I think, 4.7. So I will make the all the submission correct.
Professor, is this an example of a random error?
This is an example of mistake. So this is not an error. This is a mistake.
Okay.
All right. Good question. And another thing that I want to show you is, here when I actually did, when I show you here in the demo, then I didn't really fix it as a the significant figures and so on. But in this spreadsheet, then I have a I fixed that number for that. So then I have a consistency of the number reporting. Okay.